Welcome to Physics Chapters. In this video, I'm going to discuss about the second property of dimensional analysis, which is to derive the relation between various physical quantities. This property is also based on the principle of homogeneity of dimensions, which say that the dimensional formula for left hand side must be equal to the dimensional formula of right hand side. Let's see how we can use dimensional analysis to derive the relation between various physical quantities. For that, I'll take one problem, and this problem is using the method of dimensions, derive an expression for the centripetal force, which is F, acting on a particle of mass m and moving with velocity v in a circle of radius r. So it means that the centripetal force is directly proportional to the mass, the velocity of the particle and the radius of the circle in which it is moving. So we can write here like F is directly proportional to m raised to power a, F is directly proportional to velocity raised to power b, F is directly proportional to the radius raised to power c. So now we have to combine all these three things. So we can say the F is directly proportional to m raised to power a, v raised to power b and r raised to power c. Now we have to remove this proportionality constant with equality sign. For that we can write F as F is equal to k. We'll put constant here, which is a constant, dimensionless constant, m raised to power a, v raised to power b and r raised to power c. Now we'll write the dimensions for force and all m, v and r. We know the dimensional formula for force is m raised to power 1, l raised to power 1 and t raised to power minus 2 is equal to, for k we don't have any dimension. For mass, the dimensional formula for mass is m, and here we have raised to power a. For velocity, the dimensional formula is L, t minus 1 raised to power b. For r, the dimensional formula is length raised to power c. So we can write this as m as it is. This left hand side is equal to m raised to power a. Here L raised to power b and L raised to power c. So this we can write as L raised to power b plus c and t raised to power minus b. So according to the principle of homogeneity of dimensions, the dimensions of m, l and t have same powers both on the right hand side and left hand side. So we can compare the powers of m, l and t. So let me compare now. Here the power of m is 1, here the power of m is a. So we can say, we can write this as 1 is equal to a. The power of L is 1, which is equal to b plus c. And the power of t, left hand side it is negative 2 and right hand side it is negative b. So my a is equal to 1. From here this will get cancelled with this. B is equal to 2. So from here we can get c. So 1 is equal to 2 plus c. So c is equal to negative 1. Now I'll put, let me mark this as equation 1. So my equation 1 is F is equal to k, m raised to power a, v raised to power b and r raised to power c. Now we'll put the values of a, b and c here. So we'll get F is equal to k, m raised to power a, which is 1, v raised to power b, b is equal to 2 and r raised to power c, which is minus 1. So this we can write as F is equal to k mv square divided by r. So this is the relationship between various physical quantities: force, mass, velocity and radius. So like this we can use dimensional analysis to derive a relationship between various physical quantities.